Jai Ma Saraswati, my dear students, very warm good morning to all of you.
Today we are going to discuss about the force, friction and pressure. So first we have to understand about the force. What is the force, right? So force, if I want to discuss, then to push something, what we require? Force. To pull something, what we require? Force. To throw a ball or anything, what we require? Force. To give the motion to any object, what we require? Force. To stop a object which is in motion, what we require? Force. So you have understand, you have a idea. Now you have the idea about what is the exactly the force, but scientifically we are going to discuss further. Okay, stepwise, understand it please.
If there is some physical quantity, okay, so what we require? Units. Okay, unit. Why we require the unit? If I want to get the measurement of any physical quantity, what we require? Units. Okay, so the units of force, what we discuss, units of force. So in three systems, MKS, CGS and SI system, what is the units we will discuss? Note down please. MKS means meter, kilogram, second. Okay. CGS means centimeter, gram, second. And SI stands for International System. In MKS, meter, kilogram, second, what we require? We require the unit in the meter, kilogram and second. So we you have to learn the formula. F equal to ma, force equal to mass multiply by acceleration. So you can define the force like force is the product of mass and the acceleration. So by this formula, by the help of this formula, we will get the units of force in different systems. Okay, MKS, CGS and SI. As we know that the mass is measured in kilogram and acceleration is measured in meter per second square. So the unit of force in MKS system is kilogram multiplied by meter per second square. That means kilogram meter per second square. The unit of force in MKS system is kilogram meter per second square. Same thing we called in SI system Newton. So 1 Newton means 1 kilogram meter per second square. Have you understand? Learn it please. Okay, very important for the examination point of view. Now unit in CGS system, centimeter gram second. The unit of mass in CGS is gram and the unit of acceleration in CGS is centimeter per second square. So the unit of force in CGS system is gram centimeter per second square. Gram centimeter per second square also called dyne. So that means one dyne equal to, note down, one dyne equal to gram centimeter per second square and 1 Newton equal to 1 kilogram meter per second square. Got it? So in SI system the unit of force is Newton. So please remember, very important. Okay, now we will discuss about the relation between the unit dyne and Newton. Okay, so what is the relation between the Newton and dyne we will discuss. Okay, got it. Now, as we discussed, 1 Newton means kilogram meter per second square. So now I want to convert this unit in the centimeter gram per second square. 1 kg equal to 1000 gram. Okay, we have written, then multiply by meter means 100 centimeter. Okay, so 100 centimeter we have written upon centimeter second square is same. Now count the number of zeros. 3 in 1000 and 2 in 100. So total is 5. So we can write 10 to the power 5 gram centimeter per second square. So we know very well gram centimeter per second square is also called the dyne. So 1 newton equal to 10 to the power 5 dyne. We have the relation between the newton and dyne, that is 1 newton equal to 10 to the power 5 dyne. Remember it please. Next, we are going to discuss about the formula. We have learned about the force equal to mass and acceleration. The product of mass and acceleration is the force. This is also called the Newton's second law, F equal to ma. Please remember it. Now we are going to formulate the formula F equal to ma. So you have to remember second law of Newton, that is force is directly proportional to rate of change of momentum. What is force? Rate of change of momentum. So we have written the formula F is proportional to P2 minus P1 upon T2 minus T1. We have to understand about the momentum. Okay, if any object of mass m is moving with velocity v, then we get the momentum by product of mass and velocity. That means what is momentum? The product of mass and velocity of the object. Okay, have you understand now the momentum? Now come to the derivation of F equal to ma. Okay, we know very well the force of any object is the rate of change of momentum. So that is P2 minus P1, rate of change P2 minus P1 upon T. So we can write the momentum as the product of mass and velocity. So mv2 minus P1 means mv1 upon T. M taken common, so remaining is v2 minus v1. Got it? Now m product of v2 minus v1 upon T. We know very well the rate of change of velocity is what? Rate of change of velocity is acceleration. So I can write v2 minus v1 upon T as a. Okay, so m a. Come to your book. Okay, so force, what is written? Any action which causes push, hit or push on a body is called force. What we read. Okay, unit of force in SI system is Newton and in CGS system is dyne. We have understand very well this also. 1 Newton is equivalent to 10 to the power 5 dyne. How it is come, we have discussed, right? So now we will discuss next topic. So many facts of force are given. The first is a force can move a stationary body. So for example, any object is placed anywhere. Okay, so if I want to uh, uh, get the motion in that object, so we have to apply the force. So by the help of the force we can give the motion to any stationary body. Second is a force can stop a moving body. For example, any object is moving. Okay, so for stopping this, what you applied? Force, right? Next is a force can change the direction and speed of the moving body. Okay, you have played the football and other things, so that time you have changed the direction of the ball. Okay, and speed also you can change. A force can change the shape and size of the body. If you push a rubber, okay, or pull the rubber, so we can by the help of the force we can change the size of the body. Understand? Next is balance and unbalanced force. Okay, balanced force means if the net effect of all forces acting on an object is zero, then the force are called balanced force. For example, you have seen here is the object and f1, f2, f3, f4, four forces are working on it, but they are the resultant of the force is zero, so that means that is the balance force. Okay, got it? Just take an example. For example, gravitational force, you are sitting on the chair. Okay, so a gravitational force is pulling you towards downside, but the reaction of the chair is upwards. So downside force equal to upward side, so that means you will be remain stationary on the chair. Have you understand? I hope you have understand. Okay, if the unbalanced force are there, if the downward gravitational force is there but the acting upward force, reaction force is not equal to gravitational force, what will happen? The chair will be break down and you will pull down. That means if unbalanced force is there, then motion will happen. So motion will happen due to the unbalanced force. If the balanced force is there, then the object is remain stationary. Remember this concept. Okay, very important. Now, unbalanced force. If the net effect of all the forces acting on an object is not zero, then these forces are called the balanced forces. We have given you the example in balanced force also. Okay. Remember these concepts, guys. Okay. We will meet in the next class. Thank you very much. Okay. Make the notes of force. It is very important for your exam point of view. Thank you.